Hello and good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course from Cisco Networking Academy, and this afternoon's video tutorial is going to be on Discovery Activity number 13, and this is going to wrap up our conversation with OSPFv2 and the discovery activities, and we're going to be taking a look again at one of the more complicated or more confusing aspects of OSPF for a lot of learners who are being initially exposed to the stub area in OSPF. And that's exactly what we're going to talk about. So we're going to dig into the stub area. We're going to look at Cisco's sort of quote-unquote proprietary, or Cisco's invention, implementation of a stub area called a Totally Stub area. And we're going to talk about the two not-so-stubby areas, which are actually defined, or I should say the not-so-stubby area, the NSSA, is defined in RFC 3101 here. And you can see it obsoletes 1587. And so we'll step back to that at an appropriate time. But as you can see here, we kind of have the same setup. Router 1 is our ABR. Right, it's an area border router. We can see that because we know that it's got an interface in area 0 and at least one or more interfaces in other non-area 0 areas. So let's go ahead and dive in here. They want us to start out on router 2. So let's go, and we're actually already in privilege exec. Let's say show IP route OSPF. And let's see what we see here. So we've got quite a bit of inter-area routing information along with an external type 2, an OE2. We've got two OE2s here, and from the drawing these are over by router 4. And then we have the inter area, again OIA, meaning this information is originating from another area, not the area that router 2 is in, which happens to be area 1, if I'm not mistaken. Let's make sure we get that right. Yeah, it's in area 1 here. And so you can see the 198.51.100 and the 203.0.113.1. Those are here on the link between the internet and router 4. And then we've got a 192.0.2.0/24 out here as well. If we were to take a look on router 3, we're also going to see something very similar to what we saw on router 2, and that is show IP route OSPF. And you can see we're actually seeing almost identical information that we were seeing on router 2 in area 1. So again, the type 3 LSAs, those are the OIAs. And we see the type 5 LSA, which is the OE2. Now remember, if I said show IP OSPF database, we are getting type 4 LSAs, right? But we don't see those in the routing table. They're here in the OSPF database because what they're doing is they're helping us to recurse. So from router 3, if I needed to go to any of this external information, these type 5 LSAs right here, I need to be able to get to the advertising router. So I look at the router ID 4.4.4.4 and I say, do I have a type 4 LSA to get to that external type 5 information? And I do. And the link ID says that the advertising router, or the guy who's holding up the sign on the side of the road that says, hey, I know how to get to the router with the router ID of 4.4.4.4, and my name is router 1 with a router ID of 1.1.1.1. And then router 3 says, well, do I have a type 1 LSA to get to router 3, or sorry, to router 1? And I do. So then it goes into the routing table, finds its way over to the ABR, which is router 1, and that's how that information is making its way over there. Now, you'll notice that when we did the show IP route for router 2, and router 3, and we trimmed it down to just the OSPF output, but you'll notice that we've got a lot of output in here, and it might be possible, just like with EIGRP. Now, it's interesting when you compare and contrast the stub feature with EIGRP to the stub feature in OSPF. In EIGRP, one of the most important, or if not the most important reason to define a router as a stub isn't to shrink down the number of entries that we see in the routing table. With EIGRP, it's all about the query domain, limiting the size and the scope of the query domain, because that can be the Achilles heel or the kryptonite for EIGRP, is the size of that query domain, the distance that those queries are having to travel across the world, across the country, etc. So we define stub routers in EIGRP to limit that query domain. Well, in OSPF, we define stub routers to reduce the size of the OSPF database. That's actually more important, or a more important reason to declare a stub than to say, oh, look, the routing table appears to be a little smaller. In both cases, with OSPF and EIGRP, undoubtedly that is a benefit, or I should say a byproduct of doing a stub router, but it is not the primary benefit. Really, it's not really the main goal, right? So we're going to go ahead now and let's go back to the drawing here, and we are going to define a stub setup here. And so again, we've talked about the 4 different type of stubs, right? There's just the stub, the plain old vanilla stub, which basically states no type 5s are going to be allowed in. And then we've got the Totally Stub, which is the Cisco sort of special sauce implementation of a stub. And what that says is that's going to clean things up even more, because then we're not going to see any type 3s, type 4s, or type 5s, with the exception of that default route, if we've got a default route that's being advertised in. And so let's go ahead and do that right now on router 1. So if we take a look at show run section OSPF, you can see that's what we've got now. Again, we are in ABR because we're connected into area 0 and at least one non-area 0 area. So let's get into global config router OSPF 1. And we're simply going to change this. We're going to say area 1 stub. So we're going to turn area 1 into a stub area. Now, again, compare and contrast with the EIGRP. We run the commands on the ABR, right? So similar to summarization, we have to do it on the ABR. When we look at EIGRP, we could declare stub anywhere, right? It doesn't matter where in the autonomous system we're doing it. We can stub any router, right? With OSPF, just like summarization, we have to get it at the ABR, right? We've got to do it at the ABR. So we say area 1 stub, and I'm going to hit enter. And what we're going to see here is and that was pretty quick, the adjacency is going to go down. Because in the hello packets that are going back and forth, there is a stub flag that gets set when I enter this command on router 1. So for area 1, right, and that would be the hellos running across that network right there, 172.16.12.0. So for dot 1 and dot 2, router 1 and router 2, the hello packets no longer match. So the stub flags in the hello packets must match, or else we're going to have this issue. And we're going to talk about the NSSA, where you can say it's got to be on the ABR, where you would say stub no summary. And if I were to bring that command back when I do a question mark, you can see I can say no summary, right? Stub no summary. I have to do that on the ABR, but on the other router in area 1, I could simply leave that with area 1 stub. So it's the most important place to set it has to be set on the ABR, because it's the ABR that is regenerating the LSAs and injecting those LSAs into this non-area 0 area. So let's go ahead now and transition to router 2, where we're going to do the same thing. And again, show IP OSPF neighbor is going to show me nothing, right? Because again, our stub flags in the hello packets don't match. So let's get into global config, And let's go ahead and say, what are we going to do here? Do show run section OSPF. It should be 1, yeah. So router OSPF 1, and we're going to run the exact same command again that we previously ran. We're going to say area 1 stub. So we turn area 1 into a stub area. We make the hello packets now have the same stub flag set, and there we go, from loading to full. So do show IP OSPF neighbors. And our adjacency is now up. So what happens when we look at the routing table? Do show IP route. What do we have now that we didn't have before? And in fact, let's trim this down to just the information we're interested in. And it's that OSPF information. So when we look at the output now, what do we see? Oops, sorry. Get that back over there. What do we see? We see we've got this new OIA. So by declaring this area as a stub, the ABR has injected a default route into the area. And what do we notice that's missing that was here before? Exactly. Where is all that external information? So this is super, super critical. We're doing a vanilla OSPF stub, right? Just a plain stub. We said area 1 stub on the ABR. We said area 1 stub on the router connected to the ABR that's in area 1. And we now have, this is an OSPF stub. And so by default, and this is auto-magically happening for us, we get a default route injected into area 1 by the ABR. And what happened to all the type 5 external information? Where did all that information go? Where are my type 5s? The 2 OE2s that we had before. I think it was 2. It could have been, maybe it might have been 3. But the OE2s, where are they? They are gone. So when we say stub, that says no type 5s. No type 5 LSAs, right? We still get the type 3s, and we get that default route. And so this was sort of the original implementation of the stub feature. And it makes sense, because if I have a default route, do I need a bunch of external information? If I were to roll back up here where we ran this initially, there's the 2 OE2s right there. So we no longer get those. But again, do I need to get all that external information if I have one path out of this area? I mean, I have to come to router 1 to get out. So why not have router 1 just inject a default route into area 1? And that makes perfect sense from an architectural perspective, right? Or from a topological perspective. If you have to go to router 1, then all I need is a default route. And so this led, and this happens often, right? This led engineers at Cisco to say, well, okay, I mean, let's take this to its logical conclusion. If there's already a default route, does router 2 in area 1, since it's already been declared a stub, do I also need all this OIA, these inter-area routes in there? And the answer to the question is no, because if you have a default and you have to go to the ABR router 1 anyway, and the way we're set up here, then it makes perfect sense that all you need is a totally stub area, right? And the totally stub is that Cisco special sauce that says there will be no type 3, type 4, type 5s allowed in here. And all you're going to get is that you're going to get one type 3, which is literally that default route. That is all you're going to get. And you're auto-magically going to get that. Let's take a look at the database first here. So show IP OSPF database. No type 4s, no type 5s, right? So this is the true benefit. And again, with hardware platforms today, right? If you look at the ISR G2s or you look at the ASR platforms, I mean, these things are Ferraris when it comes to CPU resources, memory resources, the processing power that's inside these. So you would have to have a pretty substantially large OSPF database before you're going to start taxing some of the higher end routers. Now, if we're talking a 1941, maybe a 2901, then, yeah, medium size link state database with 100,000 entries or something like that, sure, maybe that's going to be a problem. But for routers like the ASR, the 1000 series or the 9000 and the higher end ISR G2s, you're not going to run into those issues. So let's go ahead. They want us to kick off a ping test here. So if I were to say ping, and we're going to try to reach the 192.0.2.1. Now remember, that's the prefix, that's the IP that's out here in the cloud, right? Out in the internet cloud. And from router 2, we don't know how to get there. Now we know we have a default route and it's going to send it over to router 1, but it's unreachable. Now what happens if I try to ping 203 and what do they want? 0.113.2. Right? So we've got reachability there and everything works out fine. So then the question becomes, well, why am I able to get to the 203 but I'm not able to get to the 192.0.2? And again, we don't have, it's all about that external information. Now the default route in the stub area gets me to the ABR, but what about the ABR? If I come over here to router 1 and say do show IP route OSPF, do I have a route to the 192.0.2? I don't. So router 1 has no default route. If I say do show IP route, there is no default route here. Gateway of last resort is not set, right? So the traffic is going to get dumped by router 1. So 2 gets it over to 1, but then that's it. In fact, to confirm that that's how far it gets, you could say trace 192.0.2.1, and you'll see, take a look. We get to router 1, 12.1, without any issues, but then that's it. We don't get any further than router 1. All right, so let's move to step number 5. Now we're going to go do some work on router 4. And we talked about the ASBR before, but now we're working with an ASBR because now we have external information being injected by router 4, who is in area 0, and is going to inject this information for us. So we come over here to router 4 and let's say show IP route. And you can see router 4 is getting all of the more specific information, and it also has a default route out to the 198.51.100.2, which I am going to guess is this, that internet connection right there. So let's go back to router 4, and what we want to do is we're going to simply originate a default route. So I'm going to say router OSPF1 default information. Did I spell that right? Default information originate. I'm going to do a question mark here. So I could hit enter right now, and that would be fine. But I want to talk about this flag here real quick, this option for always. And the always option means even if I don't have a defined static default route on this router, it is still going to advertise a default route into the OSPF area. So again, typically you have to have the static route defined. In fact, if we say, let me come back here, we'll do Control U, and we'll say do show run include route. My guess is there it is. So there's the static route. Now, if that wasn't there, I could say default information originate always, which means that if that static went away from the routing table, that it would still advertise the default. And so we'll throw that on there just in case. And it's good to know that that option exists. Okay. So that's on the ASBR. Now on the ASBR, if I also say do show IP OSPF database, let's take a look at the database here and see what we've got. You can see we've got type 5s, we've got our summary type 4s, we've got the type 2 because there's a DR on that segment, and then we have our type 1s, the two routers in area 0, which are router 1 and router 4. So we've injected the default route. Let's go back to router 1 and see what the routing table looks like now. And there it is. And again, it's coming out of the static protocol, right? Out of static route is how we originated it. So it is an OE2. Again, external information for our quad zeros. And so now this would resolve our ability to be able to ping from router 2 out to, and we should be able to trace as well, and there we go. We can trace out there, works great. Can I ping out there? Absolutely. So everything's working there. So now the ABR is now receiving the default route that got injected as a type 5 LSA. All right, so let's go ahead now. And now we're on step 8 if you're following along. And now what we're going to do is we're going to introduce the Totally Stub area, which is Cisco's sort of, like I said, secret sauce, where the engineers said, well, wait a second, if I'm saying show IP route OSPF here, so, you know, if I'm saying I'm going to put a default route in here and there's only one way to get out, it doesn't make sense to have all that other inter-area OIA information. It's meaningless. I'm not going to be able to make a more informed decision other than to say I have to go to router 1 for everything anyway. So let's do a Totally Stub. And that's where we get into, let's jump on router 1 first. And that was where we talked about that stub no summary. And so it looks like we're going to do this on area 2 here. So let's say, I'm pretty sure I'm in there, router OSPF 1. So we're going to say area 2 stub. And if I do the question mark, you can see we're kind of limited to what they're showing. So if I were to pull up, let's get a real Cisco router up and available here. So if I were to go into a real Cisco router and say router OSPF 1, and then say area 1 stub question mark, you can see we get the same options. But if I pull that back, this is where you'll see some additional options as well. And so let's go back to here and let me make sure we're seeing everything the same. Okay, good, we are. All right, so we've got area 2, we're going to say stub, and this is how you make it a Totally Stub, is by saying area 2 stub no summary, right? So that means no type 3s, no type 4s, which are a ASBR summary, and by virtue of the fact that we're not going to allow type 4s into this area, we certainly aren't going to allow type 5s, because without the type 4, that type 5 information, we have no way to recursively figure out, hey, how do I get to the ASBR advertising that information? So we say area 2 stub no summary, the adjacency goes down right away, and again we're in area 2 here, so let's get on router 3, and we're going to go into global config router OSPF 1, and I'm going to say area 2 stub. Now I could say no summary here, there's nothing wrong with that, but the no summary option only needs to be on the ABR. It doesn't need to be on the router that is in the area, okay, that is connected to the ABR, to which we're prescribing it to be a stub. So I'll throw it on here. We'll just say stub no summary, right? This is going to bring everything back up. Let's hit enter a few times. And let's see, can we ping out to 192.168 192.0, 0.2.1. All right, we've got reachability all the way out to the internet, so everything's working great. But let's take a look. Do show IP route OSPF. So that is a Totally Stub. A Totally Stub says all you're getting is a default route. That's it. That's all you're going to get. The ABR is going to inject a default route into a Totally Stub area because, again, the use case is there's only one way out. So I don't need any more specific information other than a default route. That is the only route that is needed by these two different areas. Now, if I had multiple connections from area 1 or 2 into the ABR, or let's say maybe area 3 connects over here to router 4, then things change significantly because now there's an alternative path. And that's when we need to be careful about, well, do I want traffic from this LAN segment over here, 192.168.3? You know, we've got a /24. I've got 200 employees hanging off that LAN segment. Do I want that traffic going out to router 1 across the WAN link, or do we go across whatever that may be? Who knows? It's Metro E, a T1, whatever. Do we want it to go that way? And so that's when we need to be a little more careful about that. So the last thing I want to talk about is the not-so-stubby area. I know this isn't part of the lab, but it's an interesting use case. You can see a not-so-stubby area here, and that's where we talk about the Type 7 LSA, where in the area, the networking information you can see there, it talks about these Type 7 LSAs, right? So if I were to force that to happen, let's say, and we're going to do it on, or wait a minute, can we do that? Let me see if we've got any external. Yeah, I'm not going to be able to do that on router 4. Yeah, I wanted to do it with some redistributed information here. So let's do this on router 2. Let's do it on router 2. So on router 2, I'm going to go into global config, interface, loopback. We'll just say loopback 2. IP address is going to be 10.2.2.2. We're going to make it /24. And the interface is already up. And let's go ahead and say, and then I'm going to redistribute this information in. So let's go into router OSPF1. I'm going to say redistribute connected. Wait, sorry, we didn't want that. We want to redistribute connected subnets, because if I don't put that subnet word in there, then, and you can see it says it's invalid, right? Because the area is going to be a mismatch type. Because what did we say about a stub area? No type 5s. So what do I have to do? I can't leave it as a vanilla stub, because a vanilla stub says no type 5s, and I'm redistributing information in from an external source. That external source being that static, or I'm sorry, the connected loopback address. So we've got a problem here. And this is where the not-so-stubby area comes into play. So I'm going to go back into, I'm actually already in there, do show run section OSPF, and let's say no area 1 stub. We're going to say, or I said no area 2, no area 1 stub, and we're going to say area 1, and this is where I say NSSA. Now you'll notice with the NSSA, there's also a no summary option, and that brings us to the sort of the fourth option, which is the NSSA Totally Stub area. And yes, as you could probably guess, it's going to wipe out all type 3s, type 4s, type 5s, to make sure I got this straight in my head here. There's be no type 3s, type 4s, or type 5s, and you basically get a default summary, and the type 7s get converted into type 5s when they get advertised along. So we're going to say area 1 NSSA, and we do that on the router 2 side. Now I need to come over here on the router 1 side. I need to say the same thing, and we're going to say no area 1 stub. I'm going to say area 1 NSSA. So now, and we should see this come back up, and there we go. We go from loading to full. So now what we should see is we should be getting, and there it is. And take a look. So now you're seeing for the first time the letter N. We've been seeing E, right, for that external information. But remember, this is information inside of a not-so-stubby area. And in the not-so-stubby area, we have type 7 information. So if I were to say do show IP OSPF database, there you go. There is, I went right by it, I apologize. there is the type 7 AS external, right? Because in order for me to get external information into a stub area, I can't do it with a vanilla stub. And I can't do it with a totally stub because no type 3s, 4s, or 5s, or I should say type 5s, are going to be allowed in there, right? So there's no type 5s allowed in a stub or a totally stub. So in order to get that external information from whatever that source may be, I have to convert it into an NSSA. So it's a not-so-stubby area because we get this type 7, but now let's go outside of the area. Let's go to router 4, and let's see how router 4 do show run, and actually not do show run, do show IP route OSPF. Let's see, does router 4 get the information? And it does. Remember we said that the ABR converts that type 7 into what? A type 5 LSA. So, do show IP OSPF database. What is router 4 going to get for that network? It's going to receive a type 5 LSA. Okay? So those 7s are self-contained in that area, allowing me to get external information into that area, redistributed in, within the same area, area 1. And if I want that information to go out, right, it gets converted from a type 7 to a type 5. And so that's your NSSA. And then again, the totally stub area is just no type 3s, no type 4s, no type 5s. And it looks very much like the totally stub, but it's an NSSA totally stub. All right. Well, that wraps up our conversation for OSPFv2 for IPv4 through these discovery activities, and this wraps up our conversation on stub areas. All right. Enjoy the rest of your day, and I will see you tonight.